Ladies and gentlemen, once again, it's FrazierNation.com Entertainment. This is your host, Timothy Frazier. We're out here, Geometry Series. We're going to go ahead, get to 2.4. I just wanted to throw everything out there first and foremost. Promethean board rules apply. Everything you see in this video is to be written in your notes. If the slide says it's optional, then it is recommended, but it's not required in your notebook. Okay, let's move on. 2.4, use postulates and diagrams. Now, if you remember, postulates was a vocab word back in chapter 1. Okay, we're going to go ahead and address this again in our vocab. The essential question, something that you need to be able to answer at the end of this lesson is, how can you identify postulates illustrated by a diagram? So here's a set of rules. Here's the picture. How can I go ahead and go between these two? Your objective that you are going to be tested on is students will be able to use postulates involving points, lines, and planes. Okay, so basically stuff that we got out of mainly 1.1, some of 1.2. Three things I need you to remember. Collinear, same line. So points that lie on the same line. Coplanar, same plane. So points line on the same flat surface. And perpendicular, if you remember from 2.2, perpendicular means meeting at a right angle. Okay, let's go ahead and get going. So we only have two vocab words, and really one of them we already know. We already know postulate. Postulate is an unproven rule that we assume to be true. Okay, so basically you just go with it. You know, if I tell you that two lines meet at one point, don't try to prove it. I don't have a list of theorems and definitions for you, but, you know, you can go ahead and just automatically assume, well, okay, well, you know, two lines make a intersection at one point. Okay. The one that's really important here is line perpendicular to a plane. So a line that meets a plane at a 90-degree angle. Okay. It's in the name, line perpendicular to a plane. So if you have any plane, and let's see if we can draw a plane right here. So if I have a flat surface, right, and I have a line that goes through this flat surface, well, if it meets at a 90-degree angle, and let's go ahead and put our 90-degree indicator here. If we have that indicator right there, remember that indicator is from the right triangles, you know, and let's go ahead and put that little red box in there. Remember, this red box means 90-degree angle. Okay, so I'm using that same right angle degree measure right here. So if a line goes through a plane at a 90-degree angle, then you have line perpendicular to a plane. Okay, next slide. So I'm gonna go ahead and let you guys write this down. I really think that the pictures that we have in the guided practice should be sufficient enough. I'm not gonna try to draw pictures through for every one of these, but you really should try to memorize these. Do not try to memorize the number like postulate 5 is this, postulate 6 is this, because as you know, there are a million different textbooks of geometry, and this is only the book that we're working with. There is no like universal postulate 5. And you might be wondering to yourself, where's postulates 1, 2, 3, and 4? Well, we used 1 through 4 in chapter 1. Okay, so that's why we only use two of them. We use the segment addition postulate, and we've used the angle addition postulate. Okay, those are the only two that we brought in from chapter 1. So we're going to start with postulate 5, 6, 7, 8. The only reason I'm using these numbers is because the homework addresses them as postulate 5, 6, 7, 8. I don't like that system. It's not a perfect system, but it's the system that we're living in. So go ahead and write these down. Put a star, somewhere in the title. These are really the meat and potatoes of this lesson. Postulate 5. Through any 2 points there exists exactly one line. Postulate 6. A line contains at least 2 points. Postulate 7. If 2 lines intersect, then their intersection is exactly 1 point. Postulate 8. Through any 3 non-collinear points, there exists exactly 1 plane. Okay. Postulate 9, which is kind of backwards. A plane contains at least 3 non-collinear points. Postulate 10. If 2 points lie on a plane, then the line containing them lies on that plane. And postulate 11. If 2 planes intersect, then their intersection is a line. So, I mean, some of these are related, like postulate 5 and 6. Those are converses of each other, okay? You can write them backwards and forwards. So, let's see, 7 and 8. Well, those are not related, but 8 and 9 are kind of related, okay? And let's see. I mean, these are just kind of the rules that we need to know and have memorized. They don't have titles. This is just like concepts you need to have memorized. So with that being said, let's go ahead and go into something kind of optional. This slide is optional. You do not need this in your notebook. Okay, this is optional, even though it says it at the bottom. This is optional. So you don't have to write this down. I recommend that you do, but you don't need to. So when you're interpreting a diagram, when you're looking at a picture, okay, there's stuff that you can assume, stuff that you can't assume, okay? So let's look at this picture, okay? I'm looking at plane P. We have a few lines. We have a few points. All these points, you can assume that they're on the flat surface, okay? Like there's not one like an inch above it. If it looks and appears like it's on the flat plane, it's on the flat plane. AHB, so AHB and BHD, you can assume that to be a linear pair, okay? You can assume that to be a linear pair. And another one would be like AGC, CGD. You can assume those to be linear pairs, okay? AHF and BHJ, you can assume these to be vertical angles. So remember, linear pair, okay? A pair of angles that make one straight line. Vertical angles, 2 angles that share the same vertex, okay? And they make 2 straight lines. A, H, J, and D are all collinear, so they all exist on the line. Okay, so that you can actually see them on top of the line. Let's see, J doesn't really have a point. There you go. And I know it's kind of blurry right here. Line AD and line BF intersect at point H. Okay, you can assume that to be true. Just like AD and CE, you can assume that they intersect at point J. Stuff that you can't assume. Well, G, F, and E, it looks like they're collinear, but you can't assume that they're collinear because you don't have a line on top of there. G could be off by like a little micron, and then they wouldn't be collinear because they don't lie on the same line. Line BF and line CE, you can't assume that, like 50 miles that way that these are going to intersect, okay? They might be parallel. They might not meet at all. So you cannot assume that this line and this line intersect. You can't assume that BF and CE don't intersect, okay? You don't know if these are parallel or not, so don't make that assumption. Let's see, BHA and CJA, you can't assume that these are the same angle measure, okay? If I didn't tell you that these are congruent, then you can't say that they're congruent. This might be 58 and this might be 59. You don't know unless I tell you. And finally, you can't say that AD and BF are 90, like they meet at a 90-degree angle. You cannot assume that unless you have the right angle indicator like this. If I said that this is the right angle, then it's a right angle. But being that you don't have that in your diagram, you can't assume that it's a 90-degree angle or that they're perpendicular. Okay? Next slide. Let's go ahead and go into the guided practice. So number one, use the diagram at the right. Here's your diagram. And what postulate can you say that plane Q and plane P is a line? Well, I'm going to go ahead and give you a little bit of time to flip back through your postulates. Yeah, I'm not going to do that. But you can assume postulates, we need a postulate that talks about two planes, okay? So here we go. We got plane Q, and actually, I don't want that to be like over there, way over there. Let's make this 3. Okay, nope. Let's make this, I don't know, like 30. Okay, that works. You need a postulate that talks about two planes, and you need a postulate that talks about a line. So I don't really want to do this, but let's look back at our postulates. Okay, so we need two planes. So here, two planes intersect, and it's talking about a line. We must be talking about postulate 11. So a good answer here would have been postulate 11. Okay? Because as we look at plane Q and we look at plane P, here's our intersection right here, line M. Okay, so we must be talking about postulate 11. Number 2, using the diagram, write an example for postulate 5, 6, and 7. Okay, so as you look back at your postulates, and we really don't have to look back, but let's go ahead and take a quick peek. Okay, so postulate 5 says that through any 2 points exists exactly one line. Okay, so we got to be real specific here. Let's say for postulate 5, we need 2 points that make a line. So let's say points B and A, okay, and we have line N. So we could say something like line N exists between points B and A. Okay? Line N exists between points B and A. Postulate 6 is the same thing. So just kind of backwards. So we would say points A and B lie on line N. Okay? Because it's a little bit different. Postulate 6 says that there's at least 2 points on the line, and postulate 5 says that the line already the points exist and you can draw a line. Postulate 6 says that the line exists and you already have 2 points. Okay, so they're kind of similar, but they are a little bit different. Postulate 7 says that any 2 lines, they intersect at exactly 1 point. So if we look here, we could say here's 2 lines, line N and line M, and they intersect exactly at point A. So we can say that lines M and N intersect at point A. Okay? So, it's a little bit different. Be careful. Okay? Go with what the postulate says. Let's go ahead and go to the next guided practice. Guided practice 3. So, if the given information stated that line PW, and that shouldn't, that should be line segment. Let's go ahead and say that. So, I got line segment QW and I got line segment PW. Need a little bit of black here. Here we go. Okay, so if we say that line segment PW and line segment QW are congruent, how would you indicate that in the diagram? Well, if you guys remember these little dashes, we can't use 1 dash and 1 dash. So if I extended this out, okay, let's extend this out. Okay, let's extend that out. And let's make this point Q. Okay. So first and foremost, we're going to want to make it look like they're congruent. Okay. And we will say, okay, well, let's see. PW and QW, we can't use 1 dash line, but we can use 2 dash lines. Okay. So here's 2 dash lines, and here are 2 dash lines. Okay. So since we already used 1, we can't use the 1s anymore, so we have to use 2. And then number 2, name a pair of supplementary angles in the diagram and explain. Okay. Well, supplementary angles, as you guys already know, means 180 degrees. A way to say that is, do we have 2 angles that make a straight line? Because a straight angle is 180 degrees. So we need 2 angles that make a straight line, basically. So let's look. So if I say like TWP, okay, so here's TWP. Let's go with this angle. And then let's say PWV. Let's take this angle. Okay, here's 2 angles. So here's the first angle. Here's the second angle. And they make a straight line. So my explanation would be angle TWP and angle PWV. Those are supplementary. So let's say are supplementary. How do I know that they're supplementary? They make a straight line. Okay. Let's see. They make a straight line. And a straight line, a straight angle is 180 degrees. Okay. So that's my explanation. Next. Let's use this example right now. And I know it might be a little hard to draw this diagram. I will put like a piece of paper on the top of the screen or the top of the phone and try to draw this out, because this is important. It doesn't have to be perfect. You know, you just need to not assume, you know, just take the information they give you. Like, you see this right angle right here? That's given to you. Where these 2 lines intersect at a point, that's given to you. So don't fret. Let's see, in the diagram, can you assume that plane S, so here's plane S, intersects plane T, here's plane T, at this line, BC? Yes, you can. And how can I assume that? Let's go ahead and type this in. How can I assume that? Because postulate 11 says that 2 planes intersect at a point. Okay, so that would be a yes because of postulate 11. And finally, explain how you know that line AB, so here's line AB, and line BC are perpendicular in the diagram. Well, you know that this means 90-degree angle, okay? This means 90 degrees, and look right here. It's indicated. You already have this in your diagram, so being that it's there already, then you would say indicated. I don't want to write this, so let's go ahead and type this out. Being that it's already indicated, you would say has a right angle indicator in the diagram. And according to the definition of perpendicular, you know that these are perpendicular. I'll meet at a 90-degree angle. So using these guided practice, they look just like your homework problems. I'm going to go ahead and upload that to Schoology. but you know what time it is. Homework time. See ya.